So these are derivations of the expression for phase velocity and group velocity. So here omega represents the angular frequency. A frequency is the number of rotations, so the number of oscillations or rotations or whatever depending on context per unit time. And because we are talking about circular motion here, angular frequency represents the number of revolutions or rotations the electron completes per unit time, and k is something called the propagation constant. So your phase velocity will be omega by k, and the formula for omega is E by h cross. The formula for k is P by h cross, where E is energy, P is momentum, and h cross is Planck's constant divided by 2 pi. So the h cross and h cross cancel each other, so it becomes E by P, which is mc squared by mv. E is equal to mc squared as we saw, and momentum is nothing but mv. So phase velocity is c squared by v, where c is the velocity of light, 3 into 10 to the power 8 meter per second, and v represents the group velocity. Now the derivation for group velocity is dou lambda by dou k, meaning change in dou omega by dou k, which is change in angular frequency with respect to change in propagation constant, which is again dou of E by h cross divided by dou of P by h cross. Again the h cross terms are going to cancel, so it will be dou E by dou P. So it is dou by dou P of 1 by 2 P squared by m. So how do you get E equals P squared by 2m? So you have this mc square or mv squared relation, right? And we also have P equals mv and kinetic energy equals half mv square. So if you equate both of those, you will get P squared by 2m. And when you're taking the derivative of that, it becomes P by m. So your group velocity is P by m, and phase velocity is c squared divided by group velocity.